Hello everyone, today we are going to learn integrate actuator and sensors with Arduino for your project. Now what is Arduino? Arduino is an open source electronic platform based on easy to use hardware and software. It is easy to use for all skills level, either you are beginner or advanced level user. It is ideal for interactive project and rapid prototyping. Its simplicity make it popular choice for rapid prototyping and learning. Now what is sensor? Sensor are anything that takes input from environment, like temperature sensor sense the temperature of outer area. Light sensor takes the light as an input, or distance sensors calculate the proximity of to object useful for robotics, obstacle avoidance, and interactive installations. There are more types of sensors, like IR sensors that sense the motion. Sensor act as eyes and ears of your Arduino project, gathering real world data to inform its actions. Now, what is actuators? Actuators are the components that takes action, transforming electric electric signals from Arduino into physical output. There are so many types of actuators, like motors, LED lights, servos. As the motor, we can use motors in farming area, and LED lights to show visual feedback. Servos are used to angular controls, and there are many more sensors like buzzer that sound beep if they sense anything. Now, the bridge connecting sensors to Arduino. Connecting sensors to Arduino involves understanding basic electronic pin configuration. There are three types of pin: a male pin, female pin, and a pin which is both one from one side it is male and the another side it is female. Most sensors have output pins that sends data to Arduino, analog or digital input pins. So, what is analog and digital inputs? Analog pins read a range of values like temperature levels, and digital pins read the discrete stress button pressed or not. Like digital pins are used only for yes or no, or the analog pins read the range. The correct wiring prevent the damage to ensure accurate data readings. Now, the brain. Programming Arduino for sensor input. Writing code is how Arduino interprets sensor data. It basically shows if it get inputs, then how the actuator or the actuator should take action. It is decided by your program. In Arduino, we have two programming language, C and C++. The Arduino IDE provides a user-friendly platform for programming. The key programming steps are: initialize the sensor pins in setup. To setup, we just start by writing the setups, and there is a keyword. It is serial.begin, and in bracket we have to write 96000 to start a program. Read sensor value using functions like analog read or digital read. For we have to write read functions that can read analog and digital data from the sensors. Process the data. Now the program should process the data, convert raw data readings into meaningful units. Now the muscles. Connecting actuators to Arduino. Connecting actuators often requires careful attention to power requirements and signal types. Some actuators, like high power motors, may need external power source and motor drivers to protect the Arduino board. In some actuators, we have two pins. One is for the read to take the power, and the another one is for ground. Some actuators, like high power motors, may need external power source and motor drivers to protect the Arduino board. It is power supply matches the actuator's voltage and current needs. Sometimes requires external power. And the second one is motor driver. Use edge bridge or dedicated drivers for motors to control direction and speed. And the last one is PWM signals. Many actuators, like LED for brightness or servos for positions, use pulse width modulation. Like if it is low, then LED glows. LED does not glow that much, and if it is the high, then LED should glow the brightest mode of this LED. The action. Programming Arduino for actuator control. Once connected, programming directs actuators to perform desired actions based on sensor input or predefined logic. This is where your project truly comes to life. Now you need essential programming concepts like using digitalWrite. Here in digitalWrite, we just write the pin name from we take the input, or it set it to high or low. If it is high, then the actuator takes the action, or if it is low, then actuator does not take any actions. Using analog write PWM for variable controls like dimming an LED or setting servo angles. Implementing conditional logic if else statement to respond to sensor data. Now we are going to see this practical on a TinkerCAD platform, which is a website used for Arduino programming in IoT for web-based programs, where you can write your code, connect sensors like all physical sensors through wires, and can see and try if the sensor or your prototype is working or not. So let's go for it. After logging in TinkerCAD, just click on create. After create, just click on circuits to add your new project of prototype. Then you will get interface like this, actuator and sensors. Here we are gonna add Arduino first. This is Arduino R3. Arduino UNO R3. In this, these are all digital pins. Analog pins. Here are some A0 to A5. Now this is power. Here two ground pins, 3 voltage pin, one is reuse and reset. Now we are going to add actuators and sensors. So first we add the PIR sensor. It is used for detect motion. Now we're gonna add buzzer. If it detects any motion, then it sounds. Now these all are our last sensors. We are going to add a LED light, a Arduino. Now we are going to connect them through the wire. Here 4 types of wire, the normal and the all types of wire, and here we can change the color also of the wire. For different sensors we can add the different. We are going to use turquoise color. For our buzzer, positive and negative for buzzer, anode and cathode for the LED, and 3 pin ground signal and power. Ground pin will be connected to the ground. Now so we can see it clearly by adjusting the sensor and actuator positions. Now the power button is going to connect 5 voltage of power pin. First we complete the now we are going to add signal, all the physical connections. After that we can going to write a code. Now we are going to use pink color wire for the LED. This cathode will be going to connect ground with ground pin, and the anode will be connected to the digital pin. If now we are going to connect buzzer to our Arduino by the orange color of wire. Positive pin will be going to add to the ground pin, and the negative pin is going to connect with the D13, which is also a 13 pin number. Now here is our all physical components are connected to each other. Now we can simulate it, where it get the object in front of PIR sensor, then the buzzer and the LED light will be start glowing. By using different color of wires, is easy for us to check which wire is connected to which port and from which sensor or the actuator or anything. Real world project, most of the people also use the breadboard for connections, sensor to connect more pins. Here is the object. Now we are going to add code to our this prototype. We can do the both. Just add the block and text, but in this prototype we are only going to use text code, not block code. So let's start the programming for our Arduino project. In this we are going to edit this pre-written program. Here we get by the start serial.begin dot in bracket we are going to write 9600, which is essential for this TinkerCAD to run your program. We get the LED bulletin, so we are going to add the pin in which we are connected the LED. We have two actuators, LED and buzzer. So on first pin mode we are going to add LED bulletin for input, not for output. We are only for input analog pin which is connected to our PIR sensor, which is pin number A1. So this A1 pin we are gonna write in code for input, which is our signal pin. So you have to write the port number in which you have just connected the signal pin of your sensor. So we are gonna write here A1 for input. Now for the output 13 part is for the LED bulletin buzzer. We are gonna write, and we just connected the LED through pin number 2 for output. So we are gonna edit the 13 from 2, and here is our setup is void setup is completed. It is now in void loop. If the sensor detects any kind of object, then it is 1, or if it is doesn't detect the digital any kind of object, A1, if then the value will be 0. So here 1 value 1, so it gonna take action. So here if value gets 0, 1, then the digital write on the pin number LED bulletin like of actuators for both buzzer actuators of buzzer and LED. We are going is 13 and it will be high. If it is high, then the buzzer will be on, and if it is low, then buzzer will be low, and the buzzer will be off means. And if in digital write pin number 2, if the buzzer if the digital pin number 2, then the light will it will glow if the digital light is high. And we are just at 1000 delay. So after 1000 milliseconds, the buzzer will start if part buzzing, and the LED will start after else part, thousands of our milliseconds program. In the first one, in the if part, we are just set high to both buzzer and value of buzzer and LED, so it will get off. In the else part, we will go on, if the value is not, we will going to low the part, we can change the delay of this milliseconds. Buzzer fast and slow. Buzzer buzz fast. So here we just change the value to low of both digital write pin 13 and the 2. Now our program is ready to run. Oh, it's C++ is case sensitive. Write in language. The spelling of input is incorrect. There are some, so just edit this. It's a spelling mistake of into input. No. it is ready. Now we can run this program. Yeah, the spelling in the serial begin, you just write the begin B of begin in capital letter. So we have to write in small letter. It is also case sensitive language, so we have to be careful about it. Now the buzzer, if we place any object, then buzzer will start and the light is also. If the ball is behind the sensor, then it so stop buzzing. Prototype and if it is the if the front of the sensor, then it start buzzing and LED will glow. In this, our LED in buzzer starts late. So for this, we are gonna zero the delay time of both LED and buzzer. So the output will make it fast. Here the object is in front of sensor, then it start buzzing continuously. So we are gonna just make some delay time to it. Now you can see that, and here is our project is completed. So you can make your own projects, and thank you for watching this video. By using TinkerCAD, you can make so many prototypes of your own projects. See if it is working or not. Here is our project is completed. Thank you so much, guys.